Hi, today I'll be talking about balancing chemical equations. So, why do we balance chemical equations? They must be balanced in order to accurately reflect the law of conservation of matter. So, let's get started. So, the first problem that I'll be showing is probably simple, but then it's an important one to know. So, you have H2 plus O2 to make water. So, let's get this set up. So you have two hydrogens, two oxygens, and you have two hydrogens and one oxygen on the right. So what you have to do is that you see that, oh, there are two hydrogens, but then only one oxygen. So you have to get the oxygen the same. So why not let's make it 2H2O. Okay, so now we have two oxygens, but we have four hydrogens. So we have to add another hydrogen over here. So we have 2H2, which makes four hydrogens and two oxygens. And now the equation is balanced. Let's try another one. So what we have with this one is that we have two nitrogens, two hydrogens on the reactant side, and we have one nitrogen and three hydrogen on the product side. So what we have to do is that we have to get the nitrogen amount the same on both sides. So let's say, okay, let's add 2 NH3. So we have two nitrogens, but then we have six hydrogens. So, okay, what does 2 times what equals 6? That's 3. So let's do 3 hydrogens. So now we have two nitrogens and six hydrogens make two nitrogens and six hydrogens. So the equation is balanced. Now let's do another one. This one has methane plus oxygen, creating carbon dioxide and water. So let's set this up. Carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. So let's get started. So we have one carbon, four hydrogen, and two oxygen on the left. One carbon, two hydrogen, and three oxygen on the right. So what we have to do is that we have to get the hydrogen amount correct, as the carbon is already correct. So, okay, let's add two hydrogens, two waters. So then you have four hydrogens, but you have four oxygens. And as we have four oxygens, we have to see how much oxygen we need on the reactant side. So, oh, let's do 2 times 2 equals 4. So you have four oxygens on the reactants. So you have one carbon, four hydrogens, and four oxygens on the reactants. And we have one carbon, four hydrogen, and four oxygen on the products. So 1, 4, 4, 1, 2 plus 2 plus 4. Yes. So 1, 4, 4. So we have this one correct. So let's try another one. So try this problem on your own. Okay, so first let's set this up. So we have K, Cl, and O. K, Cl, and O. So we have 1K on the reactants. We have one chloride and then 3 oxygen. We have 1K we have 2K on the right. We have 2Cl on the right, and then we have 4 oxygen. So first of all, we have to get the potassium and the chloride on the same amount on both sides. So let's do 2. So it'll be 2, the K will be 2, Cl will be 2, but then oxygen will be 6. So what we have to do is we have to get it to an amount where we can basically have the oxygen on both sides be the same. So what would 6 and 4, what number can they make? They could make 12. Let's try 12. So 6 times what equals 12 is 2. So you have to fix this and do 4. KClO3. 4 times what equals 12? That's 3, right? So you have 4 KClO3 makes 3 KClO4 plus KCl. So let's check our work. So the potassium is 4, Cl is 4, and oxygen is 12. Now, over here, we have 4 potassium, 4 chlorides, and 12 oxygens. So both sides are balanced. There are some other resources that you can use from extra problems. I'll link them down. Thank you very much and have a nice day.